Ladies and gentlemen, welcome back to the workshop. It is a good day to be here. I am starting a brand new amplifier, and I haven't done a full build from scratch in a long time, so I've been really looking forward to this one, especially because I designed this amp about 5 years ago, something like that, and this is one that I've been wanting to build for a very long time. It started out as basically a hybrid between a Vox and I'm drawing a blank, Vox and a Supro. And so I had this Supro Vox hybrid design all drawn out. And as I was getting ready to do this, I started ordering the parts, and I could not find the right transformers because everybody was just out of stock on the transformers that would work for that project. So it was going to be a 6973 power amp based on the Supro amplifiers that use those same tubes. And then, so there would be elements of the Supro circuit and elements of the Vox circuit, and like I said, a hybrid of the two. In the end, I had to go with 6L6 tubes instead, and because I couldn't find the right transformers. So I decided, well, since I've got this this deluxe reverb output transformer sitting on the shelf and not being used for anything, maybe I should make a 6V6 amplifier instead. But then it occurred to me, I can easily use 6L6s with the deluxe reverb output transformer. I'm going to do a separate video on why that works. So check in the description below. I'll post a link there. There's going to be a separate video for the beginning of this series that talks about some of the more technical aspects of this build, how I came up with the design of the circuit and choosing the transformers and so on. But I talk extensively about why 6L6s work with a deluxe reverb output transformer in this amplifier, and why it's really not that hard on the amp to use it in a regular deluxe reverb as well. The output transformers actually can handle it long term, and I'll explain why in that video. So just check that out when you have time. But getting back to this, it ended up being a 6L6 amplifier, and so I decided, well, maybe instead of doing a Supro and Vox, maybe I'll do a Fender and Vox, and that's what this is going to end up being. It's going to be kind of a hybrid between a Fender, what's the 59 Bassman. I can't think of the circuit. Anyway, it's going to be kind of a hybrid between 59 Bassman circuit and Vox. And not any specific Vox, just kind of taking some creative cues from various different Vox circuits. So a lot of different elements from Vox, a lot of different elements from Fender. So I figured Fender, Vox, I'll call it the Foxer. So this is going to be called the Foxer, and it should end up being about 30 watts, somewhere around there. It's going to be cathode bias, like a Vox would be. It's going to be using a 5U4 rectifier, 6L6 power tubes, and the preamp section is going to be very similar to a Tweed Bassman or 59 Twin. Because of that, and because of the fact that it's already very close to a Marshall, early Marshall, I'm also going to make it possible to use KT66 power tubes. I'm going to have a switch on the back panel so you can switch between 6V6, 6L6, or KT66. So I'm going to put the schematic up on the screen here, and I'll point out a few things. The input stage here, you can see it uses the parallel triodes, just like you'd see in vintage Marshalls or Bassman or Tweed Twin. And what I've done is the top channel here uses a Fender, actually the same value used in Marshalls as well, so a Fender/Marshall coupling capacitor value. And then the bottom input uses the much smaller Vox input coupling capacitor, the 470 picofarad. Also on that more Voxy channel, the second input, I've got a fixed 47 picofarad bright cap on the volume control. Now looking back up at the Fender input here, I've got this Brilliance Control. This is something that I put in a lot of my amplifiers because it's a very effective way to dial in the right amount of top-end sparkle. So basically it's just a variable bright cap. So I'm going to start with a 220 pico. I may end up changing that just after doing some listening. But that's the value that I've used in a couple of other builds that worked out really well. So basically what happens is, as you turn this control all the way down, your bright cap is out of the circuit for the most part. I mean, it's got a, 3 meg resistor in front of it. So it's, for all intents and purposes, it's out of the circuit. And then as you turn it up, it bleeds more and more of it into the circuit so that you've got a variable bright cap. And it's very useful. So between that and being able to blend the two inputs, you should be able to, we should be able to get have a lot of control over the top end in this amplifier and kind of blend between Fender and Vox sounds that way. Moving over to the tone stack, the starting point for the tone stack is the Vox tone stack. Now you'll notice here that instead of using a 1 meg pot with a 47 or 50 picofarad treble capacitor, I'm using a 500K pot and a 100 picofarad capacitor. And the reason for that, this is very important why I'm doing this. The reason is because I feel like it. That's pretty much it. That, and I wanted to be able to use all 500K pots, but there's really no other reason for that. So this switch is going to switch in a couple different treble cap values. And the other side of the switch here is going to, actually this is going to be, I forgot about this, I ended up changing this to a rotary switch. So I'm going to have a 4-position rotary switch, and it's going to switch different treble capacitor values. It's going to change the slope resistor here. It's also going to switch in a 0.68 cathode bypass capacitor in the preamp. So basically you're going to get 4 positions. The first position would be just as Voxy as we can make it. Second position will be a little more Fendery. Third position will be pretty darn Fendery. And then the fourth position will be almost Marshall. So I think we'll be able to get a lot of different sounds out of this amplifier. So onto the phase inverter. Component values in the phase inverter I think are identical to what you'd see in a Vox. Long-tailed pair with 47K tail resistor. So there's nothing fancy going on here. It's just a standard Vox phase inverter. And then on the power amplifier, the power tubes, we've got our cathode bypass, or our cathode resistor here for the power tubes. And this will be switchable between a couple different values, again, so that we can use 6V6, 6L6, or KT66 tubes. Now, one of the things you'll notice here, going back to the phase inverter, I've got a variable negative feedback circuit here. The reason is the Vox, I don't know, is it all Vox amplifiers or just most of them, but I think all Vox amplifiers have no negative feedback. Let me say that in a way that makes a little bit more sense. I think that no Vox amplifiers have any negative feedback in the power amp. So I wanted to be able to blend between that sound and something more like a Fender or even a JTM 45 with lots and lots of negative feedback. So that's what this control is doing. It's just as you turn it up, it's bleeding off the negative feedback to ground, and so that's going to give us a lot of control over the feel of the amplifier and how it transitions from clean into distorted sounds. So that'll be a nice control to have on there. Now another reason I'm really looking forward to this build is because this is going to be a full-on eye candy build. Normally I try to keep things fairly neat inside the amplifier, but I don't usually go all out. This time I am. And so I've got these gold-plated turrets that we're going to be using. And I've had some circuit boards made. This is a PCB that is made for if you can see these pads, they're oversized so that the turrets will actually sit in there. And then when I stake them, I'll solder them just to kind of tack them in place a little bit better. But this, I think, is going to look really nice with those gold turrets. And so everything in this amplifier is just going to be nice and pretty. So I'm looking forward to that. I've also got, actually I've got it sitting right here. This is the handle that I'm going to be using. But this, I've got this a little dusty now, but crocodile skin tolex that I'm going to be putting on this thing. Yeah! That's going to look so nice. So, yeah, I'm definitely excited about this one. So I'm going to go ahead and get started. I can't wait to see what that turret board looks like when it's all staked. Now, since my staking tool has disappeared, I had to improvise, and I do plan on making more of these in the future. I've ordered several of these circuit boards so I can make additional ones. And so what I've done is I've taken one of the circuit boards and I drilled out these the pads where the turrets are staked. I used a 5/32 drill bit, and then that's big enough for the top of the turret to fit through, but then this bottom, this base will not fit through that hole. So that holds it firmly against the circuit board that is actually going to be getting the turrets. And basically I'm just going to line it up like this, and there's going to be a little bit of play in here, so it'll take me a minute or so to get it just right on here, and I'll just kind of use I've got a pin here I'll use to bump these over just a little bit so that they'll drop in there. But then that'll give me the ability to stake them all very quickly. So now we've got these all lined up, and I think this will make the job a little bit easier. It's not a perfect solution, but I do think it'll save me a little bit of time. One thing I noticed as I was doing this is that some turrets had a slightly thicker base. So it's like they came from different batches or maybe a different supplier altogether. So I had to make sure that these all had the same thickness on their base. Otherwise, I'd have high spots here, and some of them just wouldn't seat real well. So I'll go ahead and put this on the drill press. And again, I don't. My staking tool is missing, so I'm going to use one of these countersinks instead, and then I'll finish it off with the flat end of a drill bit. I would much rather just have my staking tool, but I'll make this work. Yeah, that's actually not too bad. It's an extra step, but they're definitely going to be well seated. And that's what we ended up with. It's actually turned out pretty good. So now I'm going to solder each one of these. The point of soldering these is just to make sure that it's got a really firm mechanical connection as well as a very reliable electrical connection to these pads. since some of the couple of the connections are actually on the circuit board itself, things like grounds. So I want to make sure that these turrets are very securely fastened to that ground. And that's what we got. Alright, so now that I've got this all done, man, that looks nice. Now I'm going to start working on the chassis. And what I've got for this, I've got a template that I'm going to basically set that down on the chassis. I'll do the first 4 holes and then tap them and then drill this, or screw this onto the chassis so that nothing can move. And the reason I'm doing that is because sometimes I have trouble with the drill bit walking ever so slightly when I'm trying to drill through aluminum. Not as bad as when I'm drilling in steel, but it still tends to happen a little bit. And I want to make sure those holes are in the right spot. So I did. I drilled all the holes through some masonite here, and then when the drill bit's in here, it's, you know, that should hold it in place pretty well and keep it from walking at all. So I'll go ahead and get started on this. Okay, so I ended up just doing 2 corners. It's not going anywhere. I don't need to do any more than that. So now I can go ahead and drill the rest of these holes. Okay, to make the hole for the power transformer, I've got this template here, and a friend of mine, he works in the same building as me. He's got a laser cutter, and so he cut out this template on his machine, and I drilled some holes where the bolts for the transformer are going to be. And I've just used some 632 screws and screwed this into the chassis. So I'll start a pilot hole here, and then I'm going to use a router to route out the rest of the metal here. And since aluminum is such a soft metal, that's not going to be hard on the router bit. Okay, so I've got my chassis clamped down to the table saw here. And my pilot hole is drilled here in the chassis. And I've never done this before, so, you know, I'm going to be extra careful with this. Take it nice and slow, because the last thing I want is for this router bit to bite into the metal suddenly and then kick back. And so for that reason I'm wearing gloves too, just in case something does happen. Make sure this is live. Yep. Okay. Okay. Well, that made a mess, but I have to say that was far easier than I thought it was going to be. So let me get all this cleaned up, and then we'll take a look at what we ended up with. Alright, got the mess cleaned up, and I think on the next cut, I still have to do the IEC socket, so I've got a separate template for that. And for that one, I think I'm probably going to lay something down on the, maybe a drop cloth or something on the table saw here, just to make cleanup a little bit easier, because that's a lot of little bits of aluminum. And that is about as clean as you're ever going to get. No burrs, no shaky lines here. Very clean. And how'd the bit hold up? I've got this unplugged right now, so otherwise I wouldn't be touching this. Yeah, I don't see any signs of dulling on the bit, which is what I expected. I mean, aluminum is no match for carbide. So I'm going to do the IEC socket over here. I have to do that a little bit differently because this IEC socket doesn't have the screw ears on the sides. It's a snap-in style. I can't screw the template onto the chassis. So I've got some double-backed tape that I'm going to put on there, and hopefully that'll hold. Alright, I'm going to give myself about 3/4 of an inch clearance from the edge of the IEC socket. I'll mark that center. So it's 2 inches, so 1 inch is the center. 1 inch center over here. Take our double-backed tape. I don't think I need to go all the way around with this. It's you know, there's not going to be a lot of force, a lot of lateral force acting on this template as long as I'm not, you know, jerking the router around. Okay, line that up again. Where's my center? Okay. Now we got to drill the pilot hole for this. Oh, that's going to be a problem. I guess I'll drill this by hand. Okay, I really didn't have a good way of securing this to the table saw, but I think what I've done here is good enough. I mean, there's a lot more wobble in the table saw itself than there is in this. So I've just got a couple of pieces of plywood here that are kind of pinched up against this and clamped into place. I think that'll be stable enough. Yeah, that looks pretty good. Okay, so now we gotta drill the holes for these power tube sockets. And it looks like about a 1 inch hole is what I'm gonna want for these. You know what? This is gonna move around too much. I need to clamp this. Otherwise that hole is going to keep drifting further and further off center. Okay, looking back, I can think of plenty of ways that I should have done this, and this is not one of them. I would have liked to have a set of chassis punches, but I couldn't find them, so I'm using the step drill bit instead. There's really no good way to clamp this down to the drill press so that it doesn't wander. So the next best thing I can do is just mark the center line on here so that I can watch it and try to keep it on center as I drill. Okay. And once again, I'm reminded, this is the world's worst drill press. Okay, I ended up finishing these with the handheld drill. And it did drift just a touch on a couple of these. But not enough to be an issue. I think there's plenty of play in these, especially with these power tubes with the elongated holes on the mounting flange. So that's not going to be a problem. Alright, so now I'm going to enlarge these pilot holes to 1/8 inch so that I can rivet these tube sockets in place. There are still some other holes that are left to be enlarged on here, but I don't think having the tube sockets mounted is going to get in the way of anything. These rivets are a little too big. The flange here is a little too big for these tube sockets, so I'm going to have to go down a size. Oh my goodness. And these things are just tiny. I'm not using those. Okay, well, can I make these work? I'm not going to do it from the underside. I could make them fit if I came up from underneath, but that would look really ugly on the outside here. So instead I'm going to grind a little bit off of the flange on one side. For what do I need? 2, 4, 6 of these. And that should work just fine. Okay, so after grinding those rivets down, I was able to fit them in here. Problem now is I can't get the riveting tool on there. So I am not going to rivet these. I'm going to have to screw them instead. And I don't think I have any 632 screws here. So that'll have to wait until the next video. But for now, I can at least get this power transformer mounted and see how that looks. I don't know if I marked these wrong or if these bolts are just bent outward a little bit. I am not quite able to get those in there. Let's see what these look like. No, I guess I just marked them wrong. Those are pretty straight. Well, that one's bent a little bit, but not... Yeah, let's see if I can straighten that a little bit. That might help me. Now, I don't have any lock washers yet, so I'm just going to temporarily put this in place. And I may end up turning this around anyway, just because of the side that each wire is coming out of. I'll have to look at the layout again and decide which way would make the most sense. But for now, hey, we got a power transformer. So it's starting to look like something. Okay, well, we got a lot done on the chassis. I would have liked to get a little bit more done. I can't mount the other transformer and the choke until I get some 632 screws. So I think I'm going to stop there. I made some good progress, so can't complain about that. Thanks for watching. Like it if you like it, comment and subscribe, and we'll see you in the next video.